Okay, now these are the solutions to the 2017 Task 2 Indices exam, and this will be in Task 1 of the 2018 exam. So another way of writing 6 squared is 6 times 6, okay? Question 2, a number is divisible by 3 if the sum of the digits is divisible by 3. So we have to look at the sum of the digits. And it says use the divisibility test to show that 9,576 is divisible by 3. So let's do the sum of the digits. So 9 plus 5 plus 7 plus 6 is equal to 27. Now that's the sum of the digits. So that's the sum of the digits. And it says the sum of the digits is divisible by 3. So let's see if we can divide 27 by 3, and we can. So 27 divided by 3 is 9, and so therefore it is 27 is divisible by 3, so which is divisible by 3, and so therefore we can say that 9576 is divisible by 3. Okay, question 3, writing this expression here in index notation, there are 1, 2, 3, 4 2's that have been multiplied by each other. So it's 2 to the power of 4 times, so notice there's a times in between those 2. So 2 times 2 times 2 times 2 is 2 to the power of 4. Then we have a times symbol. 3 times 3 is 3 squared times 5. Now you don't need to put 5 to the power of 1, but you could if you wanted. Next question, write down the factors of 12. Now the factors of 12 are 1 and 12 are a pair. 2 goes into 12 and its pair is 6, so 2 times 6 is 12. 3 is a factor of 12 and 3 times 4 is 12. So really if you're doing factors it's good to put the pairs with each other. And the factors of 30, again 1 and 30. 2, well that's 30 is even, so 2 will go into 30, so 2 times 15 is 30. 30 is divisible by 3 as well. 3 times 10 is 30. 4 is not a factor of 30, but 5 is, and its partner, 5 times 6 is 30. 7 does not go into 30, 8 doesn't, 9 doesn't, and we've got up to 10, so that's all of the factors of 30. Now, the common factors. I'm just looking for some of the high ones. The common factors are 6. 3 is common, so is 2, and so is 1, but the highest common factor is 6. Okay, now for question 5 to complete this factor tree. So 216 is 8 times 27. Now 8 is 4 times 2 and 4 is 2 times 2. Now I know this hasn't been brought down in the diagram, but this 2 you can bring down here so that you don't forget about it. 27 is 9 times 3 and 9 is 3 times 3. Now I'm going to bring this 3 down as well. There are all multiplication symbols between these. So therefore, to write 216 as a product of its prime factors, I've got 2 times 2 times 2 as a product of its prime factors in index form. Instead of writing 2 times 2 times 2, I will write 2 cubed because that's index form, times 3 times 3 times 3 is 3 cubed. Now, it says, hence find the cube root of 216. So remember, a cube root is when 3 numbers multiply by each other give you that number. So what I'm going to do with this 2 cubed times 3 cubed, as we know it means 2 times 2 times 2 times 3 times 3 times 3. That means I have 3 pairs. Really, I have 3 pairs of 2 times 3. And there's another pair of 2 times 3, and there's another pair of 2 times 3. So the cubed root of 216 will be 2 times 3. The reason is 2 times 3 times 2 times 3 times 2 times 3 is 216. So we know that from here. But I'm just grouping a 2 with a 3, a 2 with a 3, and a 2 with a 3. So the cube root of 216 will be 2 times 3, which is 6. Okay, now, question 6. The expression square root of 9 times 4 is equivalent to one of these. Now, what you should do is work out each one. So the square root of 9 times 4 is the square root of 36. So square root is like brackets. You must do the 9 times 4 first, which is 36. And the square root of 36 is 6, because we say what times what gives me 36. And 6 times 6 is 36. So the square root of 36 is 6. Now the square root of 94, that is not a square number, so I'm just going to leave that one at the moment. Now the square root of 9, I have to do each one separately, is 3 plus, because 3 times 3 is 9. And the square root of 4, what times what is 4? Well, 2 times 2 is 4. So the square root of 4 is 2. And so 3 plus 2 is 5. Now we can see that this expression up here, which equals 6, does not equal that. So B is not the answer. Now let's look at this one. The square root of 9 is 3 times, you have to do the square root of 9 first, you get 3, and the square root of 4 is 2, and 3 times 2 is 6. So therefore, this is the correct answer, C. 36 does not equal 6, so that's incorrect, and the square root of 94 lies between, it's between the square root of 81 and the square root of 100, so it lies between 9 and 10. So it's not correct. Its value is between 9 and 10. So it's not correct, okay? That would be if you received this question in a non-calculator part of the exam. Okay, now the next question here is to simplify this expression. And we've got 2 cubed. Now that 2 cubed means 2 times 2 times 2. So I'm just going to write it out, what it means. 2 times 2 times 2 plus 2 times 5 squared. Now 5 squared means 5 times 5. So now I'm going to put this 5 times 5 in brackets if you want to work that out first, okay? So just writing what 2 cubed means, 2 times 2 times 2. Now 2 times 2 times 2 is 8, so we've worked that out, plus 2 times, now 5 squared is 5 times 5, which is 25. So this is 8 plus, we have to do the times, remember our multiplication with BODMAS, or BIDMAS, before addition and subtraction. 2 times 25 is 50, so this will be 8 plus 50, which is 58. Now what you could have done, instead of writing it out like this, on the side, this is probably not a bad idea to do, you could have just worked out that 2 cubed is 2 times 2 times 2, which is 8. And you could have worked out that 5 squared, so you could just work out 2 cubed and 5 squared first. 5 squared is 5 times 5, which is 25. Then you go straight from this first line to this line here. It's probably easier. Okay? Now for question 8. Natalie's mum is buying hot dogs and hot dog buns for the family barbecue. Hot dogs come in packs of 12 and hot dog buns come in packs of 9. Natalie's mum wants to buy the same number of hot dogs and hot dog buns. And what is the smallest total number of hot dogs that Natalie's mum can buy? So let's look at our hot dogs. If she buys 1 packet, she'll have 12. If she buys 2 packets, she'll have 24. If she buys 3 packets, she'll have 36. And if she buys 4 packets, she'll have 48, and so on. And the hot dog buns, if she buys 1 packet, she'll have 9. If she buys 2 packets, she'll have 18. If she buys 3 packets, she'll have 27. And if she buys 4 packets, she'll have 36. And 5 packets, she'll have 45, and so on. But we can stop now because 36 is in common. Now, what we've actually done here are the multiples of 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, and so on. And the multiples of 9. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, and so on. And we can stop there at 36 because we now have the same number of hot dogs and hot dog buns. So the question is, what is the smallest total number of hot dogs that Natalie's mum can buy? Well, she can buy 36 hot dogs. Or, really, it's 3 packets. Okay? And if we want to know about hot dog buns, 36 buns, or 4 packets of buns. Okay? So she'd have to buy 3 packets of hot dogs and 4 packets of buns. Okay, now for question 9. Mrs. Parker is a PDHPE teacher and she's got 25 girls and 35 boys in her class. And she wants to divide the class into teams of the same size, where each team has the same number of girls and the same number of boys. So it doesn't mean that each team has, let's say, 3 boys and 3 girls. It just means, so it doesn't have to be the same. So I could have a team with 3 girls and 4 boys or something, but each team would have to have that. So now she's got to be able to divide this whole class up evenly, and we need to see what number we need to see the factors of 25 and 35 that are in common. So if we look at 25, the factors are 1 and 25, and 5 times 5 is 25. So that means I can divide 5 into 25. And if we look at 35, the factors of that are 1 and 35. 5 goes into 35, and so does 7. So I can divide 35 by 5, and I can divide 35 by 7. So, but I need to see which one of these, so which of these factors are the same. Okay, so 5 is the highest common factor of these two groups, of these two numbers. So therefore, with the girls, so girls in each group will be 25 divided by 5. So I've got 5 girls in each group. And the boys in each group will be 35 divided by 5, which is 7 boys in each group. So that means it says if Mrs. Parker forms as many teams as possible, how many boys will be in each team? So what's going to happen in each team? Each team has 5 girls and 7 boys. So there will be 7 boys in each team. Okay? So, and we're going to have 5 groups, and there will be 5 groups. Okay, so we're going to have 5 groups of 12 students. And in each, not each term, each group. So each group, this says group, 5 girls and 7 boys, and there'll be 5 groups. So the answer is 7 boys in each team. Question 10, at the North Head Lighthouse, 3 lights are flashing. We've got light A, which goes off every 2 minutes. Light B will go off every 3 minutes. And light C will go off every 5 minutes. And it says, if the lights are flashing at the number of minutes indicated below, and they flash together at 6 p.m., find the time that all 3 lights will flash together again for the first time. So I'm going to start off with light C. It flashes at 5 minutes, after 10 minutes, 15, 20, 25, 30, 35, 40, and so on. Let's look at light B. It flashes every 3 minutes. So 3, counting, then it will flash after 6, 9, 12, 15. Now that's in common, but I don't think the 2-minute light will go off at 15. 18, 21, 24, 27, 30. I'm just going to stop there for a minute. Okay, so let's see what's in common. 5, 10, no. 15's in common. 20, no. 25, 30 is in common. Now, when I count up by 2s, am I ever going to get 15? No, but I will get 30. So I've got 2, 4, 6, 8. Now you can keep going, 10, 12, but you will eventually get to 30. 12, 14, 16, 18, 20. Now you can just go ... 22, 24, 26, 28, 30. Okay, now 30, if we look at all those lists of numbers, 30 is the first number that we see that is the same. So therefore they will flash together again after 30 minutes. So flash together again at 6 p.m. plus 30 minutes, because they first flashed together at 6, which is at 6:30 p.m. That's the end of that section.